Hey everyone, welcome back. We're learning about semiconductors. In the previous lesson, we learned about three-terminal semiconductor devices. Do you remember what we learned in the previous lesson? We learned about bipolar junction transistors and a field effect transistor. Now in this lesson, I'm going to walk you through four-terminal semiconductor devices, which means these are devices that have four terminals through which current can either flow in or flow out of the device. Now there are two types of four-terminal semiconductor devices, a photocoupler and a half-effect sensor. If you're going to focus more on a photocoupler in this lesson and learn more about half-effect sensor in the next lesson. Now do you remember what are the two terminals of a diode called as? They are referred as the anode and the cathode. Similarly, the three terminals of a bipolar junction transistor are called as the collector, emitter and the base. The three terminals of a field effect transistor were called as the source, drain and gate. Now what are the four terminals of these devices called as? Now don't worry, there's no such thing because they are just combinations of two diodes or a diode and a transistor. A combination of a diode and transistor gives rise to five terminals. Now, one of these terminals of the transistor are being left free or it's grounded for increasing the efficiency of this device. Now let's see what's a photocoupler. A photocoupler is also called as optocouplers. Now from the name, it's very evident that it has something to do with light. Now take a look at this diagram. Now this is how a photocoupler works. Simply put, these devices are just a combination of a light-emitting diode and a phototransistor. We've learned individually about these two devices. Now, this is a symbol of an LED and this is a symbol of a phototransistor. So LEDs are devices that emit lights when a small amount of current flows through it. So there are different colors of light that can be emitted depending upon the amount of energy that's required to excite the electron to surpass the band gap and reach higher energy states. So the color is corresponding to the wavelength of the amount of energy that's being absorbed by the electrons. Now, if we need white light, we usually use many layers of phosphorus on a semiconductor devices. However, for a photocoupler, we ensure that usually infrared LEDs are being used. And there's a reason behind it, because we don't want light to get distorted when it reaches the phototransistor. Because infrared rays usually have higher wavelength and it can travel a longer distance without any energy being lost. So yeah, LEDs are a device that emits light when current flows through it, and this light falls on the transistor and it senses this light and causes current to flow through the device. Now did you notice that there's no actual electrical connection between these two devices? There's just light being used for current to flow. So, photocouplers are good isolators of circuits and it can still cause current flow in it. Now, let's see in detail about the operation of a photocoupler. Now, once a small amount of current flows through the LED, the light is being emitted because of the energy that's being absorbed by the electron and getting excited to higher energy states. So light is emitted as photons. Now we said usually infrared LEDs are being used. Now once this light falls on the phototransistor, the light is being sensed by these phototransistors and causing current flow in them. So yeah, infrared LEDs are used. And this LED is not only used to sense and emit light, but they're also used to build symmetrical bidirectional optoisolators. That is, for building a device that can sense the light from LED and making current flow, we need a symmetrical circuit. So LEDs help in building such symmetrical circuits and a bidirectional optoisolators. Now, we also know that different types of photosensors can be used in this photocoupler. These photosensors, what do you think they do? They detect the incoming light that comes from the LED and falls on them, and they generate electric current directly, or they modulate the electric current flowing from an external power supply. So let us see what are the different types of phototransistors that could be used. We could use photoresistors, a photodiode, silicon control rectifiers, drag, and a lot more. Now take a look at this diagram to have a better understanding of what are the different types of phototransistors that could be used. Now, we know that photocouplers are just a combination of two devices, LED and a transistor. So LED remains fixed because we need light to be emitted, but a phototransistor, there are many types of transistor that can sense light. So a normal transistor could be used to detect light and generate electric current, or we could use a photodarlington. Do you remember what's a darlington? It's just multiple layers of a transistor, especially bipolar junction transistors. Now, using multiple layers will increase the accuracy, or that is the accuracy of sensing light and emitting more current. We could also use a silicon control rectifier or a triac. A triac is nothing but a triode alternating current, and these are bidirectional devices. That is, it could conduct current or generate electric current through either of the directions when they are being triggered and light is being sensed by them. So yeah, there are different types of transistors that could be used to sense light and emit current. Now, since there's no electrical connection between these two devices, optocouplers are good isolators of two electrical circuits. Now, this is how a photocoupler looks like in the real life, with 6 pins. Like one side of the photocoupler is the LED, having the anode and the cathode. Now, we could actually connect resistors with the anode to resist the current. But why do you think we are trying to resist current here? Because our aim is to make the LED emit light and not to flow a lot of current through the LED to emit light. So we ensure that just a small amount of current is passed through LED and light is being emitted from it. Now, we could also connect resistors between the collector and power supply to increase the efficiency, and we usually leave the base free. So one side of the optocoupler has the LED and the other side has the phototransistor of the base, collector and the emitter. Now this is how we can electrically symbolize an optocoupler. And yeah, finally, we leave the base terminal of the phototransistor left free, or we ground this terminal, because we need the phototransistors to have high efficiency from the falling infrared light to sense and conduct current, because we know that in bipolar junction transistors the collector current is significantly very high when compared to base current. So yeah, we've come finally to the end of this lesson. Long story short, in this lesson we learned about the meaning of a four-terminal device, and we saw that there are two types of four-terminal devices, a photocoupler and a half-effect sensor. We learned the working of a photocoupler, and we also saw how photocouplers are built. In the next lesson, we'll be learning more about half-effect sensors and what's the difference between photocouplers and half-effect sensors. Well, thank you for watching and stay tuned for more. If you have any queries, please ask me in the comment section below.